Very good morning.
Good morning, sir.
Morning, sir.
Good morning. Good morning. Do you able to hear the morning prayer?
No, sir.
No, sir.
Okay, okay, okay. Nothing to worry. Are you able to see the slides?
Yes, sir.
Yes.
No, sir.
No, sir.
No.
Wait for a minute. It will come. Now,
No, sir.
No.
now.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, okay. Yes. So today onwards, we are going to start the actual syllabus, which you really need to study and which you really need to understand well. Uh, with this, we are going to start the overview of the syllabus. As it was discussed in the previous class extensively, we have discussed atomic structure and chemical bonding, electrochemical energy system, and all those photochemical and solar energy, all those things are there. So coming to this particular one, atomic structure and chemical bonding, what actually has to be discussed here? Atomic structure and chemical bonding. So here we have to discuss how exactly atomic structures are there, why it is so, why this particular atomic structure is only possible, why not a different one. All those things will be there here. And chemical bonding. Say in this particular thing, or in this particular slides, or in this particular curriculum, what you are understanding is fundamental particles of atoms, their mass, charge, location, atomic number, mass number, Schrodinger equation, all those things you are learning in a very comprehensive manner. No doubt about that. Along with that, you also study VSCPR theory, VBT, MOT, formation of electrovalent coordination compound, chemistry of weak interactions, especially van der Waals forces and London dispersion force, including hydrogen bonding. Including hydrogen bonding. So, yeah. So, very first thing what we are going to understand here is atomic structure and various models which you have already learned in the +1 +2 Bohr's model. Electrons revolve around the nucleus in circular orbits, angular momentum, mvr, nh by 2 pi. All those things I don't want to extensively discuss here, right? A wave mechanical concept, quantum mechanics rejects the idea of fixed orbits and all those things. See, now here comes with the Bohr model and all those things. Now, question comes, very first question comes here with respect to this particular fundamental discussion is why the quantum number comes to the picture here. The question to the student community, why the quantum number is required? Why the quantum number is required? Can anyone address this particular question? Why the quantum number required?
To get the position of the electron.
You are telling what exactly quantum number does. But now I am asking you why quantum number is required. Why it is required? See, with quantum numbers, definitely you can find out what is that, where exactly the electron and all those things. Why do you need? That is the question. Why do you need quantum numbers?
So because electron shows dual nature,
Because electrons,
shows dual nature, sir.
because electron shows dual nature, that is why you require quantum numbers.
To
Yes, sir.
describe an electron in an atom.
Why do you need to describe an electron in an atom? That is what the
To, dis-
question actually.
to know the stability of the atom.
To know the stability of the atom.
Sir,
Well,
to find the configuration of electron.
To find the electron shell energy level.
why do you need to know electron shell energy level? Why do you need to know the atom? Why you have to understand regarding with respect to the atom?
So the
To
electron
know how they
configuration of
behave,
atom.
sir.
Determine the electronic configuration, sir.
To know how they behave, to determine the electronic configuration, to find out the electron. See, all these things are very true. Yeah, I'm not saying that you are not telling the correct answer. You are telling a partially correct answer. So, why you have to study about the atom?
To know the basic idea.
Why do you need to know basic idea?
So because all electrons are made up of atoms, sir. Means all particles are made up of atoms, sir.
You mean to say that entire energy is made up of matter or something like that?
Yes, sir.
Any other answers? Any other answers? Please mute yourself. There is a lot of background noise. Who's that? CG Priya. Lot of background noise was there. Yeah, that's very. Thank you. Thank you so much. Why do you need to know the quantum number? Why do you need to know the electron? Why do you need to know the atom? All those things are really a very mind-blogging question you have to address. Yeah, I'm getting some answers. Somebody is trying to answer.
To know and understand chemistry easily.
To know and understand chemistry easily. If you know quantum numbers, will you be able to understand the chemistry of that particular quantum numbers?
Sir, all the matter in the universe is composed of atoms, so we need to know what is happening inside it. So we use quantum numbers to represent the electrons.
Okay. Most of them, what you people have said, the answer is more or less, partly it is correct. Why? Because to understand the electron, to understand the dual nature, to find out the address of an electron, all those things, and as you rightly said right now, to understand the how the matters are made up of and all those things. Yes, that is very true. See, if you really want to understand the nature, if you really want to understand how the materials are formed, if you really need to understand how the things or stuff are being made, you need to understand the raw materials. You need to understand the what exactly it is made up of. If you want to understand what exactly it is made up of, you have to understand or you should know what is the raw material is used. So in this particular case, the entire world or the energy or the matter, the world is made up of matter. E is equal to mc square. Energy is made up of matter, right? E is equal to mc square. That's what the famous E is equal to mc square formula says. So with this, what you can understand is that if you understand the basic nature of the electron, if you understand the basic nature of the electron, you can definitely predict, or you can definitely know very well, or you can definitely assume, or if you definitely understand how they behave. The behavioral concepts of the electron can be understood by using quantum numbers. So before going to the quantum numbers, you should know this particular fundamental concepts. That is what actually wave mechanical concept and quantum mechanics. So in this case, uh, orbitals and orbit are coming to the picture here. What is orbital and orbit? You could see here orbit and orbital. Definitely, questions they can frame for the exam. Differences between orbit and orbital. Differences between orbit and orbital. So in that case, you should write these 4 5 differences actually. Orbit, what exactly orbit or what exactly orbitals. See, with this difference, you could understand orbit comes from Bohr model, orbital from wave mechanical model. What exactly orbit? It is a circular path followed by electron. Orbit. See, orbit is nothing but a circular path followed by electron. Here, orbital is not the circular path. It is the region of space where probability of finding an electron is maximum. See, for this, I could give you one analogy so that you can understand better. What exactly the meaning of region of space where probability of finding an electron is maximum? What exactly it is? It is, say for example, if you are observing soccer players or football players in the football ground, where exactly you could find a maximum number of players, definitely around the football. Around the football, you could find maximum number of players. So if you just take the aerial view, what you could say, that is the region of players, that is the number of players where exactly that particular number of players who are fighting for to get the particular football in their control, that is what the region of space where you could see the number of players. So similarly, in the very same concept, you could find a region of space where probability of finding an electron is maximum. That particular space we call it as orbital. That particular place we call it as an orbital. Here, orbit represents 2D motion of electron around the nucleus. 2D motion. Here, represents 3D motion. What exactly the meaning of 2D and 3D? See, 2D means it's only a two-dimensional and you could find a particular orbit. In the orbital, you could find three-dimensional motion, x, y, and z, or x, y, z. Now, however, you can call it as x, y, z. I mean, in the x-axis, y-axis, z-axis, the probability of finding the electron, the probability of finding the electron in x-axis, probability of finding the electron in y-axis, probability of finding electron in z-axis. This defines what? This defines the shape of the particular electronic configuration of an atom. Shape of an atom, molecule or an ion. Shape of a molecule, atom or an ion is described by an orbital, not by an orbit. Orbit is only a 2D motion, whereas orbital is a 3D motion. And orbit, as you already know that, contains 2n square electrons, whereas orbital can only hold only 2 electrons. Only 2 electrons. Orbit is always in circular path, whereas orbital is in many shapes. I told you it is in many shapes. It's in many shapes. So this is the basic thing one should know before understanding the atomic structure, before understanding the wave concepts and Bohr concept. You should understand what is the differences between orbit and orbital. See,
Sir,
yeah, please.
sir, orbital only two shapes are there, no, sir? Spherical and dumbbell.
Who told?
Sir,
You are telling only spherical and double. What about double double? What
Sir,
about
that also dumbbell shape only, no, sir.
who told? A spherical is not there.
That's what, sir. Only two, no, sir.
Double double is not there.
Oh, no, okay.
Complex is not there.
Huh?
Complex F orbital is in very complex nature.
Oh.
You don't know that?
No, sir.
That definitely. I appreciate your question. I appreciate your timely question. Why? Because now you are understanding or you are upgrading from don't know to I know. Little bit I know. That's really a good concept. Better, please try to ask. If you don't know, you see, when you say don't know, it's a tremendous possibility to getting knowing the things. I really appreciate if you ask question, definitely you can come to know. That is why I always want, even if it's a silly doubt, even if it's a funny doubt, even if it's a wild doubt, even if it's a weird doubt, please ask yourself a question and let us understand in a better way. Orbit and orbital both are having a clear differences. With this, I will
Sir,
ask once again, have you understood
excuse me,
these
sir.
particular, yeah, please.
Sir, in this, after knowing all this, which concept is correct, sir? Bohr or wave mechanical means orbit or orbital?
See, both are correct only. Both are correct. I am trying to distinguish between orbit and orbital. I am not saying this is correct or this is wrong. Both are correct. Orbit is one particular parameter, orbital is another parameter. So we are trying to get the differences between or distinguish between orbit and orbital. Orbital is entirely different thing, orbit is entirely different thing. We are trying to differentiate or we are trying to understand a better concept. Okay?
Yes, sir.
Yeah, very good. Moving further, moving further, we are coming to the quantum numbers. We are coming to the quantum numbers. See, as you rightly told in the very first beginning of the class, why quantum numbers are required. Quantum numbers, as you rightly told, most of them as told, correct one. What is that? Quantum numbers are actually an address of an electron. Quantum numbers is mostly an address of an electron. See, if you want to locate the electron, you need an address. You need a GPS location. You need what is that? Just like a WhatsApp. In WhatsApp, you share the location, live location, or something like that. So a pin-to-pin GPS is required. A pin-to-pin clarity is required in order to locate the electron. Now you can ask, why do you want to locate an electron? If you want to understand the nature of a particular atom, you should understand what is the electron configuration, or what is the electron, or how many electrons are involved, what are the different types of electrons are involved. All those things you should know in order to understand a better molecular structure or atomic structure or ionic structure. If you want to understand these particular basic concepts, before moving on to the macro dimensional, you should understand for nano dimensional or micro dimensional concepts. The nano and micro dimensional concepts, these quantum numbers. Quantum numbers, definitely finding or understanding the quantum numbers will lead to the bigger facts and figures. Identification numbers of characteristics of electrons used to define the electrons in an atom completely. If I want to locate any particular student in particular college, I should understand or I should know what is his registration number, what is his parent name, what is his name, where he is from, which subject he is studying, which branch he is in, which classroom he is in, and ultimately it is just like a Aadhaar card number. It is just like a Aadhaar number. By knowing the Aadhaar number, I can easily locate that particular person. Similarly, here also the quantum numbers are like that. Everybody know what are quantum numbers, but why do you know quantum numbers? I am giving the little bit of clarity with respect to this particular one. So each quantum number represents or refers to a particular character. Everybody knows that. Everybody knows that. See, there are four quantum numbers as it is listed in this particular slide. Everybody is seeing it. Principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. All the four are different characteristic properties. All the four quantum numbers are different characteristic properties they do have. See, a principal quantum number explains the size of the electron cloud. See electron cloud. Here afterwards, when you say electron, it is not a single entity, it is a cloud. It is a cloud. I hope everybody has hearing about cloud computing or cloud storage being a very younger generation to me, even compared to me or myself. You are all younger generation. You might be understanding better than me cloud computation or cloud storage and all those things. Similarly, here also, when I say electron, yeah, up until the first PU, second PU, electron is a single electron. That's what you have read it. No, electron is not a single electron. It's an electron cloud. Electron cloud. So, with respect to the principal quantum number, the size of the electron cloud you can discuss. The size of the size of the entire particular quantum number describes about size of the electron cloud. Size, azimuthal quantum number, size, azimuthal quantum number, shape, magnetic quantum number, orientation, spin quantum number, spin angular momentum. So size, shape, orientation, spin angular quantum number, spin angular quantum number. So the four quantum numbers, they do describe four different aspects: size, shape, orientation, and spin. These things they are defining. By knowing these things, you can locate an electron, you can find an address of an electron in an atom or a molecule or an ionic compound. Have you understood this particular concept, my dear students?
Yes, sir.
Yeah,
Yes, sir.
yeah,
Yes, sir.
very good. Moving on to the next one. Moving on to the next one. In particular, what exactly this principal quantum number? What exactly the meaning of size? All those things we will understand. Refers to the principal shell to which the electron belongs. To which the electron belongs. Say it tells about the average size of the electron cloud. It tells about average size of the electron cloud. Before jumping at this particular one, how exactly nucleus looks like? Nucleus looks like, say for example, if you keep a football in the center of the football stadium, if you keep the football at the center of the football stadium, and if you go to the 100, 200 meters up above the football stadium and take an aerial view, you could see a football ground and at the center a football. It is something like that. The entire nucleus is assumed to be like this. Means without having a players, football and football ground. Football is actually a center of the nucleus. Football ground is a nucleus where exactly you could find proton, neutron as it is in the case of football, and the entire nucleus is in football ground. If you ask me, if you ask me, Sir, if I see from the 100 meters above the football stadium, everything looks like a wide volume. Yes, definitely. You are very true. You are very true. The entire nucleus looks like a wide volume. It doesn't have anything else. It's a wide volume. So that is why I told you orbital comes to the picture means this is a region of space where the probability of finding an electron is maximum. That is what actually orbital comes to the picture. Similarly, in this particular case, principal quantum number says what? Principal quantum number refers to electron belongs, where exactly electron belongs, and size of the electron cloud, and position and distance away from the nucleus. It contains 2n squared. So principal quantum number can be designated with different letters: K, L, M, N. K, L, M, N. So using or applying this particular formula 2n square 1, 2, 3, 4. Where n is 1, you could find 2 electrons. Where n is 2, you could find 8 electrons. If n is 3, you could find 18 electrons. If n is 4, you could find 32 electrons, and so on, and so on. So what is the essential property, or what is the essential character you are picking up here is each letter or each shell K, L, M, N can accommodate these many number of electrons. How many number of electrons? 2n square number of electrons. 2n square number of electrons where n is equal to 1, 2, 3, 4. 2 electrons, 8 electrons, 18 electrons, 32 electrons can be accommodated. By accommodating these number of electrons, the size of the electron cloud may vary. The size of the electron cloud will be designated, or the size of the electron cloud will be designed or depicted or told by principal quantum number. So in conclusion, principal quantum number decides the size of the electron cloud. Principal quantum number decides the size of the electron cloud. Principal quantum number decides or designates by the letter designation KLMN. It can hold or it can accommodate the electrons with respect to the 2n square where n is equal to 1, 2, 3, 4. Now question comes here. Why n starts from integer 1, 0, 1, 2, 3, 4? Why not from 0? Question to you, my dear students. Question to you, my dear students.
Sir, can you repeat the question?
Sir, when orbitals is zero, then there is no electrons, no, sir?
That's a very good question, actually, very good answer, actually. If n is equal to 0, means the entire concept of existence itself is questionable. So when we are questioning or when we are addressing the principal quantum number, we need to have something. That is why the integer or the number, that letter designation or a principal quantum number always starts with 1, 2, 3, not starts with 0, 1, 2, 3. If it starts with 0 means it's empty, it is no need to discuss that. So that is very particular, correct one. So principal quantum number is already discussed, and I hope that you don't have any question with respect to principal quantum number. Can I move on, my dear students?
Yes, sir.
Yes,
Yeah,
sir.
yeah. Thank you so much for your kind approval. Next one, azimuthal quantum number. Azimuthal quantum number, as I told you, it defines the shape of the orbital. See, shape of the orbital. First one is size. Second one is shape. Third one is orientation. Fourth one is spin. Sauce. See, yes, yes, oh, yes. Yes, yes, oh, yes. Size, shape, orientation, spin. Size, shape, orientation, spin. Right? Yes, yes, oh, yes. If you remember, definitely it will be easy to understand and easy to remind and easy to remember and easy to reproduce in the exam. So azimuthal quantum number describes the shape of the orbital. What exactly the meaning of it? We have to understand thoroughly. It represents the spatial distribution of electron cloud. See, that's what very good. Spatial distribution. When I say spatial distribution, it comes around three-dimensional structure. Three-dimensional structure. X-axis, Y-axis, Z-axis, something like that. For a given value of n, for a given value of n, the L can have values from 0 to n minus 1. This is the formula you have to remember. Each of which is called a subshell. Subshells are symbolized as S, P, D, F. Very beautifully designated. Very beautifully designated. Can anyone tell me what is the meaning of SPDF? What is the SPDF stands for?
So sharp, principal, diffused, and
Short,
so
principal.
sharp, principal, diffused. F, I'm not sure, sir.
Yeah, yeah, very good, very good. So sharp, principal, diffuse, F. Anybody can add on to that F?
Fundamentals.
Fundamental. Very good, very good. Sharp, principal, diffuse, fundamental. These are the different. What is it? Acronym for the this one what they have used. So here, for a given value of n, say for example, if n is equal to 1, if n is equal to 1, the L can have values from 0 to n minus 1. L can have values from 0 to n minus 1. Say for example, if n is equal to 1, 1 minus 1 is 0. 1 minus 1 is 0. If n is equal to 2, if n is equal to 2 means 2 minus 1 is 1. So if that is the case, it can have values from 0 to 1. See, look at this. Value 2, 0 to 1. Value 3, 0, 1 and 2. So now subshell, yes, SP, SPD. Now you tell me, in this particular case, we are trying to understand, yes, orbitals are in which shape? Yes, orbitals are in which shape? Spherical.
Spherical shape.
That's a very beautiful answer. Very beautiful answer. I really appreciate that. Can you please tell me, how do you come to know yes orbital is spherical in shape? Who is that assured S orbital is spherical in shape? I think one girl and one boy has said. Who is that? Could you please tell your name, please? Nothing to worry. No need to worry. We are here to learn. I'm not here to demoralize you, or I'm not here to criticize you. We are here to learning. Can you please tell your name? Who said S is equal to spherical in shape?
Tejita, sir.
Uttejita, I really appreciate your answer.
And me, sir.
Yeah, nothing to it, nothing to it. I appreciate you. Me means I don't find any me here. Can you
Harshavardhan,
please?
sir.
Huh?
Harshavardhan.
Yeah, that's good. I thought me means it's a Redmi phone. Harshavardhan, okay, fine. Harshavardhan and Uttejita has given wonderful answer. Yes is in spherical orbital, spherical shape. Uttejita and Harshavardhan, if you know, or anybody else, if you know, how do you say that yes orbital is spherical in shape? See, this is what actually a next generation level thinking. Why it is spherical in shape or how it is in spherical shape? Has anybody seen the spherical shape? Has anybody has taken using a Canon DSLR camera, or Nikon DSLR camera, or iPhone? With iPhone, anybody has taken S orbital as a what is a spherical shape? Has anybody has taken this photograph and posted in the status and posted in the WhatsApp or Instagram? Has anybody did it?
No,
These are
sir.
just predictions, sir. We don't actually see S orbitals or S and P them, so we don't see them, sir.
You are telling that it's a prediction.
I think it's
Sir,
an
by the
experimental
movement of
value, sir.
electrons, sir.
Experimental observation.
Experimental observation, moment of electron. Somebody is saying moment of electron. Who is that moment of electron? I said.
By
Raghunath, sir.
evaluating psi value, we can get no, sir.
By. I'm getting correct answer. What is that?
By
By.
evaluating psi value, sir. Wave function, slow the wave.
That's a wonderful answer, man. Who's that actually?
Abhinav Srikar, sir.
Abhinav, I really appreciate that you had given a very wonderful answer, which most of them might not be understanding or knowing that. See, nobody has seen this particular one. Do you understand? Do you see? Before coming to that, I would like to say one thing. I would like to ask one question. Has anybody seen electron?
No, sir.
No, sir.
No, sir.
Nobody has seen the electron. Correct? No. Nobody could see electron, but without seeing electron, how can you define an electron? And
Sir,
how can
because
you
of its negative charge.
uh,
Because of its negative charge present there.
negative charge present there? No,
Yes, sir.
my question is, nobody has seen the electron, correct? No. Without seeing an electron, see the funny thing of the science, without seeing the electron, people have described that electrons are particle in nature, electrons are vehicle in nature. For that, they received Nobel Prize. Do you understand what I'm trying to convey the message to you people?
Yes, sir.
Nobody has seen the electron, but irony is that they could decide, or they could predict, or they could conclude their nature. Without seeing the electron, they could conclude their nature, and for that, this one, they have got Nobel Prize. That's the irony part. Let us not discuss that particular one. Now coming on to this particular azimuthal quantum number, why the S is a spherical in shape is after solving the mathematical wave function after solving the mathematical wave function using Schrodinger wave equation for this particular s orbital, you will get a curve function in a spherical form. You will get a curve function in a spherical form. Please don't ask me, can you please derive it and show me? Why? Because I am not that much talented with respect to the mathematics. Since it is not my domain, I have not understood how exactly they have solved this particular. It's a big derivation. I could show you, that is not a problem. But thing is here is that why this particular spherical shape? After solving the s orbital with respect to Schrodinger wave equation, you will get a curve function which fits into the spherical shape. That is why it is s orbital in spherical shape, p orbital is in double shape, yeah, and d orbital is in double shape, and f is a complicated shape, right? So all these shapes are obtained using a mathematical wave function. See, that is the beauty of mathematics. That is why I told you in the very first beginning of the class, chemistry is colorful, mathematics is magicful, physics is powerful, biology is beautiful. That is why, where see, if you are trying to understand little bit of with the common sense, why mathematics? See, you right now you are, I think you are already understanding differential calculus and integration and all those things you have studied in +1 +2, and here also you are understanding partial differential equation and everything. Correct? No? Are you studying all those things in your engineering also?
Yes, sir.
Yeah, if that is the case, where do you use all these partial differentiation and integration calculation in your day-to-day life? In day-to-day life, you are nowhere using this partial differentiation or integration and all those things. But if you come to the R&D, if you come to the research, if you come to the practically, if you think that where exactly it has been using, it has been using in higher model, algorithm model, artificial intelligence, and all those things, you require this particular fundamental mathematics. See, that is why I try to ask you, please try to ask yourself why and how. Why we are studying this? How these things are happening? What is this I am studying? Where is it is going to be useful? If you ask all these things, you will have end-to-end applications, and you will find the most interesting thing. So here, SPDF, why it is a or why azimuthal quantum number describes the shape of an orbital because of this. It can have the value from 0 to n minus 1, 0 to n minus 1, and subshells are symbolized as SPDF. Do you have any queries with respect to this? If you have any queries, please raise. I will give you 1 or 2 minutes break. 2 minute
Sir,
break. Yeah, yeah, please.
Sir, S means spherical, P means dumbbell, and spherical. Like, sir, what are they exactly, sir? Like, are they the structure of and how the electrons are located, or what? What is it, sir? Like, how do we?
Yeah. Very beautiful. Uttejita Reddy, right?
Yes, sir.
Yeah. It's a very beautiful question you have framed actually. What is this actually? What is this actually means? S orbital is in spherical shape means what does it mean means if you go through in any axis, x axis, y axis, z axis, or in all the 360-degree, the probability of finding electrons in s orbital is you could find electron in all the 360-degree. Do you understand, my dear Uttejita Reddy?
Yes, sir.
In s orbital you could find electron in any 360-degree. That is what in all circular path you could find electron in any possible location. Whereas in the case of p orbital, I hope you say, if I say p orbital, do you remember in +1 +2, do you have understood px, py, pz? Do you understand?
Yes, sir.
Yeah, px means what? Px means the probability of finding the electron. We all know that p orbital means dumbbell shape. The dumbbell shape is oriented on x-axis. So in the px, you could find the electron in x-axis, whereas py, pz are 0 for that px orbital. Try to understand, my dear students. In the px orbital, you will find electrons, most of the electrons in the x-axis, px orbital, whereas py and pz for the px orbital is 0, whereas most of the electrons could find on px orbital. Whereas in py, you could find it py or y-axis, pz and px are nodal planes. In the z-axis, pz, you could find. See, that is what actually probability of finding the electron can be found out with the orbital. Px, py, pz, pxy square, px square, y square, pxy, x square minus y square. I hope you have studied. But thing is that you have not taken the pause and you have not questioned yourself. What is it? Just like you have questioned, what is it actually? That kind of question can leads you to the answer. That is what I am asking you, my dear students. Forget about chemistry. If you try to ask yourself why I am studying engineering course, what is this electrical and electronics communication and electronics and electronic communication, and most of the engineering courses, why it is like this, why not like this? Simple question if you ask, you will understand a better analogy, a better concept, and better knowledge so that nobody can question you once you complete your degree. And once you go to the interview, interviewer will mesmerize after seeing your knowledge. No doubt about that. This is how you should learn the subject, not simply collect the facts and figures and omitting on the time of exam. Everybody will do. As I told you, when I given an option, this computer, Google search engine is the master when compared to anybody else in this world. Whatever you ask, it will gives you the information. Do you think that Google engine is a masterpiece of this planet? No, it's only a facts and figures. It tells about facts and figures. That's it. So collection of facts and figures will nowhere help you. Asking question, WH question, till you perform, till your life, if you ask like this, you will be able to understand. See, actually, in fact, that is the motto of Indian education. But unfortunately, what we are seeing is Western education. Western education is what they are doing is they hush up the questioning ability. They suppress the questioning ability. They normalize. They simply tell you just do what I say. That is what Western education. Why? Because they want robots. they want slaves, they want followers. Whereas the Indian education, Gurukula system, what we had in the thousands or 2000 years ago was a fantastic education. What is that education? In which field you are in excel, in which field you are having passionate, that field you are going to continue. But here now, nothing like that. If you are interested in philosophy, even then you have to completely be a BE graduation. What is this? BE is nowhere related to philosophy, right? So same thing. What I am trying to convince you here is you should understand the question, you should understand the concept and ask the question so that you will better learn more thorough knowledge. Any other ideas, any other questions? So do you really want to understand? Have you understand why principal quantum number is important? Why azimuthal quantum number is important? Students, I'm
Yes,
asking
sir.
you.
Sir.
Yes, sir.
Yeah. With this, I'm going to wind up. I think 8:30 to 9:20, right?
Yes, sir.
Yes, sir.
Yeah. Thank you very
Yes.
much. I really appreciate your coordination and questioning ability. Please do interact like this. And my sincere question is, my sincere urge or my sincere request is, try to question yourself till your life. You will be excel yourself at the end of your life. No doubt about that. Please do it honestly and learn the subject with the knowledge, conceptual knowledge. Thank you very much for your kind cooperation. Thank you so much.
Thank
Thank
you,
you.
sir.
Thank
Thank
you.
you,
Sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you very much.
Thank you, sir.
Thank you. Thank you
Thank
so
you,
much.
sir.
Thank you. Thank you very much.
Sir, stop the recording.
Thank you. I'll do